Okay, I guess we're going to get started here. Welcome to another Common Lisp study group. I'm your host, Ram Vedam with Atlanta Functional Programming. Today we're going to be discussing Chapter 18 on from Practical Common Lisp, which discusses the format macro. Now, those of you who are familiar with the language may also be aware that this macro is a fairly it's a very involved macro. Like the library, it's a separate language itself almost. And it consists really of three sub languages. Um, uh, and depending upon your usage, you might encounter some of them, especially if you're in legacy code bases or even in code bases where they particularly pick one subset of the macro usage to actually display their error messages or print out to standard out and so forth. Um, to get things started here, I wanted to give a bit of history here when that was mentioned in the book that I thought was pretty neat. This macro is one of the few things that have been around since really the early days. Um, I think Common Lisp actually picked up this macro and this style of formatting from earlier Lisps that trace all the way back to even older Lisp that competed with Fortran. Primarily because some things in the macro, the format function itself, dealing with string formatting, which we'll discuss a little bit later, uh, dealt with really printing out fixed width strings out to a string. Uh, you may not encounter this when you are using newer code bases, but certainly older code bases will leverage this when they need to, because that's actually how they created their tools. Um, so I thought I'd at least mention that because it is a very interesting point in terms of how the macro evolved over time. But because of that, there is a bunch of stuff that is honestly available for this, and even the chapter itself on format doesn't cover absolutely everything. So what I'm going to be doing at least is for certain things that I know of directly, I'm going to go ahead and sort of augment the information that's in this chapter, and hopefully that will help some people out. To get things started, let's just go ahead and look at some code. So some examples, a lot of examples, and a lot of formatting string interpolation utilities that whether in Common Lisp or in C have your pretty standard, um, format arguments for primitive data types. So like things like strings, integers, floats, and so on. I'm going to show you a couple of ways to deal, particularly with floats, some of which was mentioned in the book, and then there's some augmentation to that, primarily with respect to one of the arguments that we'll talk about shortly. To start with, at least printing like normal things for 90% of people, like if you're just dealing with just a primitive Lisp object or even a class object that has some sort of method that you hooked in with the pretty printer, which we will not be covering in this talk specifically, but certainly we'll talk about it later on, primarily because the pretty printer is a pretty big system, but it allows you to essentially take objects that you've created, whether they're being user-defined or even data formats, and allow the REPL to print them in a particularly human-readable way. But sans that, you can also, if you're using primitive, um, uh, objects or primitive types, use the tilde a argument to actually go ahead and print something. So like, let's say that we wanted to print an integer, it will go ahead and print an integer. Let's say that we want to also print a list. This is a list primitive type, and it has something that ties into how the pretty printer works. So format will go ahead and print it in the most readable form that is available for that particular object that overrides it. Of course, as you can see here, if we're doing like even like floats, we can, start typing it in, and based on the number of options that you could certainly, type in, get the most readable format there. Let's try the pi example that I'm going to be talking about shortly. A will give you the entire sort of a max fixed width of the decimal number and provide you with some extra readability information here towards the end. This I'll discuss when we start talking about a format option called tilde f. But let's just take this beginning part, for example, and go through some options there. Instead of using tilde a, you could also use tilde $sign to actually go ahead and print this. And by default, as I mentioned in my notes here, and I will certainly put this up at the end of this talk, it will default rounding the decimal to two decimal places. The floating point number will go to 2 decimal places. But if you want to get more than 2 decimal places inside your floating point when you're dealing with it, you can certainly do it in several ways. One way is specifying the number of decimal places you want to round to directly in the format string itself. Like in this one, we'll round to 5. You can also specify it in format by saying tilde v $sign, which just says, okay, eat the next argument, and the next argument will represent the number of decimal places that I want you to round to. And when you print it out, it will go ahead and round it out to 6 decimal places. Now, I haven't tried this yet, but while you guys are watching, let's see what happens. Certainly this should fail, because then, and as you can see, it will fail. If you type in the wrong argument, it will complain that it is not a number, because it's expecting a number in the format string. Other things that you can do is, well, format will be able to, take in a number of arguments and then count them, and then use that to round to the decimal places. So in this case, let's say that we do using tilde hashtag $sign pi. Since there's only one argument being passed after the format string to format, what you could do is if when you return, it will round to only 1 decimal place. If you type in multiple, you can see that it's going to ignore everything, just using count of it to actually go and round the first argument into the REPL. The next thing that you could certainly do with format, and again, this is particularly with floating points, just primarily because floating points are easier to talk about, but you could certainly use this generic argument for anything, much like tilde a, which stands for aesthetic, by the way, to actually control the formatting. And this is one of those arguments that actually goes back to how they were dealing with tabular data. In particular, you can this argument tilde f allows you to provide up to 5 different arguments, and if there are particular arguments that you want to provide and other arguments that you want to ignore, you could just simply use commas to actually say that you want to ignore them, because they don't actually they're not actually of use. But what are these 5 arguments? So I had to actually make sure I get these right, because it's been a while. Well, if you look at other material on the net, particularly I actually had a copy of ANSI Common Lisp lying around. I thought I'd actually explain to you what those 5 arguments are. So the order in which they're going to be in is the following. 5. These are your arguments to, let's say that and I'm just labeling them this way so that you can actually understand when you guys take a look at my notes once they're submitted, it'll help you as a reference. The first argument is a total number of numbers to be printed, actually. So like if you wanted only 15 numbers of a 30 number thing to be printed, it'll go ahead and print out 15. it defaults to the exact length of the number itself. So like if the number is like a huge number, it'll go ahead and try to print out everything. The next argument is particularly with respect to the decimal. So this will allow you to specify number of digits to print after decimal. Now, while in tilde $, you are defaulted to only 2, this guy actually defaults to all of them. So it'll print as much as it can from after the decimal to the end of the string, and it'll print them out to standard out. The next one is related to shifting, really, but it's not shifting as you think, like, spaces, remaining spaces. What it is if you have a number, and I'll show you an example of this, and you wanted to multiply it by 10, you could tell a format to shift the actual digit a certain number of digits to the left. And it will, behind the scenes, shift it to the left, which is effectively shifting it base 10. And by default, this guy is obviously none, because you saw earlier in some of my examples, it didn't actually shift anything. And I'll give an example of all that too as well as we go on. Number 4 is within your fixed width based on argument number 1. If you max out the width of that and there's still more numbers to be printed, you can actually tell Common Lisp to print a special character to represent, that there are more numbers, but I've only printed this number of numbers to the console. And that is what this 4th argument for. It's for the special character to print when there's overflow, display overflow. Finally, the last argument is really what special character do you want to print before the start of the display? Like if you, and again, since this is fixed width, I would have to show you an example of how this would actually work. But this character is literally your fill character. I call it the fill character usually, but I don't know what other people will call it. So let's take this example that's here and use this as our example using pi. So by default, you saw what the previous example. I was rounding to 5 decimal places. If I wanted to round to 5 decimal places, obviously I could certainly use tilde comma 5f, and it will go ahead and do that for me. But what if I wanted to have maximum 10 characters rounded to 2 decimal places? We don't shift anything to the left. Let's say that we want, we have display overflow, we'll do a star. And let's go ahead and obviously these have to be atoms. So you need to do, and you have a space here. And you want to print out pi. This, as you can see, shifted because we only have 3 digits. It now gave me a fixed width of 10 digits there, and it's using a space now to fill in the other 7 digits when it's displaying this. So you can use this, and you can see that this can be used to actually create very nice formatted data. Any questions so far? Cool. There are other things here that we could talk about too as well. In format, there's obviously something that you can use to print integers. As you can see here, we could print million, but if we do tilde d, tilde colon d instead of tilde d, it'll actually specify a comma separator, and it'll print out 1 million. In fact, let me do this one more thing. So in between each things, if you want to create a new line, you can actually use tilde%. And I'll add these to some of these examples so it will make it easier to see the differences. So let's try that again. Okay. So this is tilde:\d, this is tilde:\d, and if you want to do tilde@d, and this tilde@d is essentially saying I want you to print this number with the sign intact, and it will display the sign too as well, as you can see there. Now obviously you could combine all of them, so like if you wanted to do sign with comma, you could do :@d, and it will go ahead and print it out that way. So there's some pretty neat things here that are available at your disposal if you want to really leverage Common Lisp to display your data in the console in a really nice way. Of course, just like anything else, other languages, we have your standard tilde hex for hexadecimal. So if we do 15, we have tilde O for octal. So let's say that we wanted to print out 15 in octal, in hexadecimal, and then of course in decimal. We could certainly do this, and well, in binary too as well. So we have these options here, XOB, to print your number that you specify as an argument in its respective form here. So if we obviously print out in hexadecimal, we'll print out F. If we try octal, it'll print out 17 because it's 8 to the first plus 7, and then here's our binary representation. Now, of course, this doesn't, in other languages, they tend to put what's the word? They tend to put the base inside and the display string, so it'll do like for F, most languages will actually display 0 hex F correctly. You would have to add that. It will just convert it. I don't know if there's another way of actually making it do something else, but this is what I usually end up adding when I'm trying to actually debug stuff. Actually, this is 0O, this is 0B. So this would be that, and this would be what else is there? There's a couple of weird languages in here, things in here that I thought was kind of interesting. Oh, there's one more thing that I wanted to talk about. So in Common Lisp, regarding floating point numbers, what I've shown only was 2 of the 4 that's really available. I've never used the tilde G directive, I'll be honest. I've almost always used a tilde F or tilde $, or tilde A when dealing with floating point, just because I never had a reason to. Of course, tilde E is there, so if you wanted to, like, say, for example, specify 1,000, it'll go ahead and create it in proper scientific notation. But the other ones I've never actually really dealt with, so I can't really talk to tilde G, unfortunately. Michael Fiano, have you ever dealt with tilde G in the wild?
Never, not once.
Okay, so I think it's safe to say that because although it's there, it's probably of historical consequence now rather than something that's being heavily used. So Unless you actually see it in a specific code, I don't encourage you to really leverage that. For floating point stuff, tilde $, F and E will probably handle 95, even 97% of your needs. On top of that, there's a couple of other, I would say, esoteric language directives that are available in format that honestly I have never seen anybody really use, but it might be used in some contexts. I can't really say yes or no. One of them are the English language directives, which I thought were pretty wicked that they actually had this. um, if you try tilde R, it will actually go ahead and translate that guy into a string representation of the number that you passed in. Now, let's say that you wanted to use the same thing, but you wanted to use Roman notation. Well, then instead of tilde R, you would use tilde et R. Let's see how this works. So, sorry. So let me do this. Sorry, I made, instead of nil, I almost always do true, so I can actually see this on the command line. So as you can see, if we do tilde et R, it'll go ahead and convert the number into proper Roman notation. And of course, there's two different styles, as with anything. There's an old style Roman numeral and a new style Roman numerals. So let's see the difference here. So if we take the same, so this is considered new style Roman numerals and old style. I'm only mentioning it like this because there are folks in literature that you might encounter that uses that notation. So if we do, tilde colon et R, 1, 2, 3, 4, and we go ahead and try and print this guy out, and remember to actually put the new line so it doesn't confuse people, you will see that's new style, and this is old style. We'll use $4 and 4 numbers instead of 5, because like if you see same thing with 9, and I think 9 is probably an easier thing to take a look at. If we do new style Roman numerals with 9, this is what almost everyone remembers it from IX. But if we do old style, it actually will, in some cases, it was written with V and four I's after it. So there's a couple things that might be useful to be there. Another one is the ability to actually, depending upon an argument, specify whether or not something is, a plural or not. I really never actually leveraged any of these, so I encourage you guys to try it out. I mean, one quick example of this would be this guy. In general, you have something called tilde P, which allows you to allow common Lisp to figure out whether or not something that you passed into the reader, particularly the format function, whether or not that guy actually represents something multiple or something single. So like in this example here, we're typing in and we're actually returning, oh, sorry, forgot the stream. So as you can see, what tilde colon P specifically does is it will pre-process an argument and then use that conditionally to figure out whether or not it needs to add an s or not to this function. So if we do 10, what it did is it took the first argument, which is 10, wrote it in English, and then it took that as the same argument to tilde colon p and says, okay, is this greater than 1? Okay, we're going to add an s to the end of this this word. So these are primarily useful for if you're again if you're trying to leverage this for like a reporting utility. One more pretty neat thing that I thought would be pretty cool to talk about, and honestly, this is where I see a lot of use for format is the the list notation that's commonly leveraged. So, for example, how would you, let's say that we have a list of numbers, all right, a list, okay, and we have 5 or 6 numbers, okay. Now, one way to actually go and look through this list is you can actually go ahead and say, and there's several ways. One is let's do list x a list, and then it'll print it. You could do it that way, or you could go ahead and use the loop macro, which we haven't talked about too much yet, but we have seen use on it to print it out. So you can use this for some formatting actually, because you could do, this is straight out of PCL. You can actually say, okay, on certain conditions, like if we're hitting, if there's a last element, go ahead and also print a comma, and it'll go through and now iterate through the list and print out commas. But you can also do this directly in format, and the way you do that is you do tilde a, well, tilde brace to indicate that you're iterating through a list. You format the list with the way you want it, and then when you're ending it, you could go ahead and close it by doing a tilde brace too as well. And in here, you will see something pretty cool. But now, wait a minute. If you notice very closely here, we actually added a comma and a trailing comma. Now, this actually happens a lot in other languages. Like you have to add some little, a little logic to make sure that that last comma is not there, either by trimming or doing a replace or whatever at the end when you're printing it out. But in Common Lisp, if you wanted to abruptly stop and say, okay, I don't want you to print anything at the end, you could use tilde caret, and this guy will go through and notice that at the end it recognizes that it is at the very end, and it will do essentially the same thing that our loop macro does. So this is a little bit more concise, as you can see, for the formatting. But obviously this is this is not as readable as, say, the the loop macro that we used earlier. And even this is not as probably readable or understandable on first glance compared to other ways of actually printing this out. But this conciseness is a nice way of at least knowing layouts of tables, which is what format was originally designed for.
You can actually modify that to make it even more obfuscated and emit the English word "and" before the 6.
Yeah, that's pretty cool.
Makes it gets really unreadable though.
Right. Yeah, I saw that. I was trying to be careful on what to show there, but yes, you're absolutely right. It's actually mentioned in the book that you can use that to say 1, 2, 3, 4 and whatever. And while that might be useful in some cases. I've never actually used it. So this is the example that uh, Michael was talking about. Let's say that you wanted to.
I actually have it open in a buffer right now if you want me to share my screen.
You may certainly share your screen, but it's gonna actually. You know what? I think I have it already here. So here, what you could do is you could certainly do this instead, which is that nasty guy. And where's my events buffer? Hold on a second. There it is. So, and if you go through and iterate, oops, that's right. If you go through and actually specify arguments separately here, you can actually see that it'll go through the list and it'll say A, B, and C. It'll now. One thing I did not notice, and maybe you can explain this to me, Michael. Like you saw in this,
that's not how I would have done it. I think there's a lot shorter form for that.
This is what I got. This is what the example. This was the nonsense example that we saw in PCL, and I was like, huh.
I forgot what's in that book. Here, I'll show you what I got.
Okay. I don't actually see your buffer, so if you can paste your thing in.
You see my screen?
I cannot see your screen. Okay. Could you just paste it into the group chat, and then we can go from there? That way I can actually just print it out.
Yeah, I got a few examples of format that I was...
Sure. Go right ahead. The more the merrier.
The chat is here. It's been a while.
The chat is the little icon in the upper left-hand corner when you're using Google Hangouts. So if you move it, you'll see it like a little menu pop out, and then you can see it in the upper left-hand corner.
Oh, there's the screen share button. Okay.
Yeah.
I don't know how readable this is going to be, but...
Excellent. Let me go ahead and give me a second, and I will print this out and show this to the world. So, let me...
Those are some the common... Well, some of them are not so common, but those are very common, most of them anyway, idioms in Common Lisp's format, DSL.
So, so for the first one, we actually go to... yes. Okay. This is the one that we were talking about. Yeah. So this is another way of actually doing this. Shoot. Should not have killed that. Hold on. So if we go ahead and pass a list to this hashtag brace is basically saying if this is a stopping condition, right, you're doing comma and then provide the tilde, correct, if I remember correctly, the bracket, the hashtag bracket notation.
I don't remember specifically what that is.
So this is a bunch of really interesting examples that Michael provided. Let's go through a couple of them. Hold on. Why did I do this? Okay. Another one that I thought was this one, inserting new lines. Yeah, this is pretty typical too as well. This tilde percent stands for new line. So think of this as the equivalent to your /n in other languages. There are certainly things for converting binary numbers here. So if we go ahead and convert this guy t, you will see that it will list out the numbers in binary, and the same thing goes for hexadecimal, as Michael has shown here. which is what we were going through earlier. On top of this, there's also something called tilde C, which will obviously take care of um, your your characters. But this actually has a couple of interesting combinations. If you do tilde colon C, and let's say that you specify a space, this will actually print out the code character for that character in a readable form. So same thing goes with, like, say, tabs and other non-printing characters. There is a nice thing that was mentioned in when dealing with characters in PCL, that on top of that you can also, if you want the explicit character, you can also do, and that is the actual, this notation here is what Common Lisp is actually printing out when it's dealing with individual characters. You can actually get that emitted too, to get the literal, what they call the literal character syntax through Common Lisp too as well. So in this case, if we do, I think, if I specify, can I do this and it will treat it as a single character? I think so, actually, if I remember correctly. Oh, right, sorry. I forgot that. No, that's right. I have to go ahead and, if I add it, it'll go ahead and print it out correctly. So this hashtag backslash is Common Lisp's literal character syntax, and it basically allows you to grab that and print it out correctly. The same notation, though, I think, if I'm not mistaken, allows you to also print the return value of character codes. So, like, if we do code character here and we print it out, we get character 97, which is also lowercase a. So a lot of interesting things there that that are available. But again, goes back to something that that I think the lesson of this chapter really is really tabular formatting. Really, like, you really leverage this to do tabular formatting.
Yeah, there's a lot of control characters to tabulate data and everything like that.
So
really powerful.
I'm going to end this this piece here, because this is particularly useful because of the example that you posted, Michael. So we haven't actually talked about this just yet, but in this example, going back to the 1, 2, and 3 example that you kindly made for us, this guy, the braces originally are called conditional directives. What the conditional directive does is you can specify a number of clauses in between them, and the directive decides to pick one of them, which is then passed into format to go ahead and display things. So, for example, let's say that you have a couple of options for printing out a list here. Like this example here, what it did is it you separate each clause by its tilde semicolon. So here we have actually a list of 3 clauses technically. The first clause is just nothing. The second clause is the comma and format that was kindly there, and then followed by the third clause, which is and that's actually the terminating clause. Otherwise, go ahead and do a comma and then continue on with the iteration. So let's take another example that came from the book, actually, that should illustrate some of this too. This is a nice one, which is, let's say you want to translate numeric values into their Spanish equivalents. So we have cero, uno, dos has being an indicator, and you are actually specifying the index into there to actually go in and say execute this particular clause. So what it does is if you pass in 0, it'll return cero, uno, and dos respectively. But you can get really weird with that too as well, has Michael shown in his example. You can specify based on different conditionals to print out specific clauses before it actually goes ahead and does what it does. We've actually seen one of this, which was when we were using. This goes back to our test framework, actually, going back a few weeks ago, which is you may remember this, which is we have a result of a test case, and based on that test case, it will be pass or fail. So that's what we were using tilde, colon, brace for. I heard somebody snap their fingers. Is that a aha moment, I hope?
Oh, that was me, sorry.
Right.
You want your mind to be really blown?
Yeah.
Have you ever seen the tilde forward slash?
Tilde / No, I have not.
That lets you call out to your own functions, so you can make your own directive.
Cool. That's really cool.
Yeah.
Oh man, yeah, that is really cool. Okay. Send me some code. Let's see that. That would be.
Just a second.
As you can see, folks, I think while Michael is actually getting his example up and running, the format, this chapter 18 on format only gives you a very nice brief tour, but as you delve into format, you'll realize it's a very rich, featureful language for tabular formatting of data, and for printing data, and this is actually separate. This format sublanguage is separate from the pretty printer, which we haven't even discussed yet. But I can briefly at least explain some ideas from the pretty printer, because we've talked about, I think, print1 and terry which is printing new lines and so forth. Those functions are also part of the pretty printer, but they don't have to be used with anything like format. If you're doing anything with tabular formatting or formatting of strings, format is your friend. So the example that, let's see here.
This example is from Common Lisp Recipes.
Which is, hold on, I'm trying to see here. You have twice output 42. There we go. Okay. There we go. Sorry, your code earlier was kind of like making it.
Yeah, that chat's not the best.
No, it's fine. So let's read through this example. This is creating your own directives. If you wanted to, you can also create your own directives.
I didn't write this code. It's from Common Lisp Recipes.
Compliments of E.D. White's and Common Lisp
9.6.
Common Lisp Recipes, chapter 9, section 6.
9-6. Yep.
Okay. Okay. Common Lisp recipes. In this example that Edie White's so generously created, and honestly, folks, as you get more and more into Common Lisp, I can't encourage this enough. Go get yourself a copy of Common Lisp recipes because he's actually gone through painstakingly and given a really nice set of recipes that will help you do everything. There's a lot of stuff in there that we haven't even begun to cover, and I think as we go on, it would be probably prudent for us to actually go and cover that book too as well for a couple of things, especially when it deals with some advanced topics. But specifically with this example, let's see what this is doing. Twice takes in a stream, takes in an argument, and has one or more arguments. It takes in one or more arguments, and what it does is it just says, okay, when you see twice, convert it so that it will actually dump out the arguments itself. So let's see what this does. So we have to first specify our compilation failed. Why did it fail? Formatter breaks on signals uninterrupted. So this guy.
Oh, it was a paste fail.
I'm assuming that it's args and arg and args.
The chat corrupted my format directive. It should be tilde a, tilde colon.
Oh, got it.
Asterisk, tilde a.
Okay. So tilde a, tilde colon, asterisk, tilde a. Yeah. Okay. So now we have. Now let's try this. Asterisks, because what does 40? So let's see what this prints out. If we print this out normally to standard out, and because it is a normal function that's just taking a stream and argument, you will see that this guy prints out 42 twice.
Yeah. Okay.
So now you can leverage this, as in this guy, to print out boot BBO.
Whoa. Maybe that one screwed up too. Let me see.
Hold on, tilde forward slash. Twice tilde a.
Try to make that a format nil instead of format T.
Okay.
That's how he did it. Ooh, BBO.
Still BBO. But I think it's because it's passing, it's taking in the first argument.
Yeah,
and then
you have
returning
the string boot in there too. I think that's just what it's supposed to print out.
What? Say that again?
Yeah, you have the string boot as the first argument, but I think that's just what it's supposed to print out, right? Because it would print out B and then O twice and then T. So I think that might have been a comment, maybe. The boot, the string.
Yes. Okay, so let me go ahead and let me see this. Yes, that's correct. Okay, got it. So now this is, which means this should also work actually, right? I mean, here. Yes. This. Let me go ahead and do this for you. Add that. There we go. So yeah, that works correctly. So what this is doing is folks, this format string, the first A aesthetic is taking in obviously the character B. In the second one, what it's doing instead is it's saying, okay, for this format, for this argument, I want you to call a function and tilde forward slash, and we'll invoke a function, and you have to close it by putting a closing forward slash so that it knows that the next argument that's there is going to be whatever is being passed in. And then finally, in this argument here, this is our last character. So what this is doing is it's going to print B with the first aesthetic, call twice on O, which is what we saw, and then prints T, which, spells boot. So that's pretty cool. You could certainly leverage that for doing even more wicked stuff. Again, going back to tabular formatting, but it's it if you're just using this as to print out your list values alone, tilde A will give you a good portion of those. And if you need more control in terms of spacing and fixed width, then just leverage tilde F, and that will get you 90% there. I personally, I use iteration a lot. I tend to use tilde curly brace, close curly brace, just because it's kind of nice to be able to just write a single line of code that does this. And once you learn it, it just becomes kind of mechanical. And I use this in 90% of my cases just because I'm dealing with collections of data when I'm playing around with Common Lisp. So that's it for format, honestly, because we can keep going with format just because there's a lot of stuff. We haven't even scratched the surface. That's I'm pretty sure what's available in the hyperspec. But I want to stop here and at least discuss any questions. Like, have any of you, Michael Gargano, Joe, or Judd, have either of you actually leveraged this, and in what ways have you guys been using it?
No, just following the book.
And I see.
Yeah, nothing too fancy. Just building strings out of conditions. So you get somewhere in the logic, and then you have a generic string template basically, and fill it. So nothing strange.
So one little quirk that I will say that I read this and I completely forgotten about it just because of how I leverage it is, but that second argument technically can take in a string, although from my understanding, it was supposed to be a stream. So one thing I wanted to ask you, Michael Piano, is there an implicit conversion from a string to some sort of stream object internally? Like if I pass in an actual string, or are they do I need to just is behind the scenes is it like talking about something like with output has string or whatever?
No, I think this is referring to the T in format.
Okay.
Rather than that's standard output, rather than nil would be a string.
Okay, but format itself is a stream. Is an actual. The second argument for format is always a stream, correct?
Yes.
Okay. So
the first. Wait. Yeah, the second. You're right. Sorry.
No, it is the first argument, but really the first argument is format, the function call, but it's the second place. It's the first argument, though. You're right. The first argument is the string.
Okay, I just typed in format yes no, and I got an error. It says the value yes is not of type, and then it's an or. It can be either. Then this is SB. This is steel bank.
Could you copy your S expression into the chat, please, so I can actually look at it?
Okay, hold on.
This guy. Format yes, no. Oh, well, you didn't specify.
Said
the first argument format can either be nil T, a string, or a string with a fill pointer.
So you could do this, which is yes, but you can't. If you do format yes, no, you'll notice in the yes is being passed into the destination, which clearly is not, that's not correct, right? So format cannot be passed in, cannot be called, or cannot be invoked without a stream, some sort of stream, some sort of destination to copy the stuff in.
Okay, so a string with a fill pointer would work, right?
Yes, like I think with output has string is what you could probably use. output as string or input as, no, I think it's with output to string x x tilde a tilde thing. Yes, I think this will work. Yeah. So if you use with output to string, which creates, what it does is it wraps the string object and makes it into a string.
With the string.
So that gives you a nice thing to do. So, but the way you were writing it, that was actually incorrect syntax.
I just tried it. Sorry.
No, I'm just saying it's just incorrect syntax. I'm just mentioning it to you so that.
Okay, thank you, Rom.
No problem, no problem. SBCL does not have a compiler bug.
I'll call you later tonight. Is this okay?
All right. So if there's nothing else, I think we're gonna end today a little early. I do apologize for the short study group, just because other priorities for school have been sort of taking up my time, so I've been kind of slowing down on doing things one chapter at a time. I do apologize to those out there in the digital realm that have been kind enough to watch our videos and our study groups and us talk about Lisp. I'm going to end with a couple of announcements, and I'm going to try and see if I can leverage good old. Let me see if I can pass in. Yes, perfect. Okay, so I want to give another plug for the game jam that's coming in a couple of weeks. It's starting exactly April 20th and ending April 30th. It's kind of nice. It's giving you a couple of. Hold on, there we go. It'll shoot. Sorry, it'll give you a couple of about a 10-day game jam for folks. You can write in any Lisp dialect that you want to. Closure, Scheme, Bracket, Common Lisp. We're nice folks in Lisp games on Freenode and game dev inside Discord. Join in and have the fun. And just ask questions. I mean, honestly, this is an educational game jam. Michael, is there like a particular submission that they have to do, or is just do they just click join jam on the site?
Just click join jam. It'll if they don't already have a profile, when you sign up, it'll let you upload a tarball or a zip or whatever for your game. It provides you all the tools to distribute your submission.
So this
so you need to sign up for an account there.
Yeah, you click on login.
Completely free. Just come and have fun.
Yeah, and we could just use our GitHub accounts to actually go through this, right?
Not sure.
Well, it looks like it does, but that's what I'm kind of curious if because if we hook in with it, you can create your own account, folks, or you can use GitHub. But in terms of submissions, where if you're leveraging your GitHub account, I don't know what the details are on how to do a submission through it. But it should be the same, I'm guessing. It'll just be using the authentication service through it. So next week, we are discussing. We're discussing a pretty big doozy, honestly. We're going to be getting started in a very detailed discussion on the condition system and restarts and exception handling in general in Common Lisp. This is a discussion that I think we're at a good spot to really talk about, just primarily because it's not as discussed when you're talking about even third-party libraries that are available in Common Lisp, which I feel kind of like this one feature really helps if you design your API to work well with the condition system in Common Lisp, and makes the Lisp library experience far more usable because it gives people some flexibility in how to leverage your library. But until next time, this is just Ram Vedam signing off. I'm hoping you guys will join us on April 20th for the Game Jam. If you guys have any questions, any topics that you want me to talk about, feel free to ping me on Slack, on the Functional Programming Slack, or on Tech 404 if you're in the Atlanta area, or on the Lisp Discord server, which I periodically squat in. But I certainly do look at my notifications when they come. But until then, I'll talk to you guys soon.
Okay, thank you.
Bye.
Thank you.